Hello again. I was a bit sick this day, so I'm with low energy today. So I will make a small task that I wanted to add to the game, and that is the possibility of making zoom in and out in the map mode. Because the game could have many levels that are far away, so the player could want to go faster than this, and also to see the large picture. So I need to add a new mode of movement, because until today I was having, I have the camera speed and the distance as parameters configurable, but fixed parameters, and this should be the map distance. It's good to have a standard distance to go to when we switch to the map, but let's change first. Let's add new input commands. Zoom in, for example. New action. Zoom in and zoom out, and let's assign, for example, the mouse wheel zoom in. Let's use this one, and for zoom out, let's use the mouse wheel down. Okay, let me check some. Now, instead of speed, we will have camera sensibility, and by default, let's use this number. Let's use camera sensibility here, and we will need to use this in conjunction with the distance to the map, because for lower distances we need low speed, and for big distances we need big speed. So position, let's use this C component, and I think this should so by default this will have okay, perhaps the default value should be a bit larger. Okay, this, I think this is the same as before, because before it was 50 and the distance is 100, so yeah. Okay, now the change I wanted to make is this. I want to unify in the map input function the camera movement or let's say 2D movement, and the camera zoom. So we need Let's check. Okay, instead of having this variable here, we need to have, we need to have a global variable the target for the camera. What's this? This is an old variable. Yeah, okay, let's use this. This is in the switch map mode. Yeah, let's use this one. I think I was not using it in other. Yeah. Okay. Yeah, it seems like I wanted to do this before and okay, let's use it. Let's replace for camera target, and we initialize it in the current position after the zoom, after the we switch. Yeah, after we switch to the map mode. Okay, now in the map input we need to camera target. Let's move itself camera target plus equals the movement. Okay, now we need to clamp. Why we are doing it like this? This could be simpler. Main map X. The clamp function takes a value and forces it to be between the min and max parameters. So we should clamp the value of y. Okay, now this we should do after we zoom and move the camera. We should, or the target, we should move the camera, the actual camera position towards the target. But this we should do it only if the new target position is different than the camera actual position. So we will compare if they are not equal. We assign it, and the problem with this, I think that the problem with this is how do I let's how do I let's print the time. Phoenix time, for example. String. Let's see if we are, yeah, this is only moving. Okay. But yeah, the problem will be the animations, but okay, let me first do the zoom. So action, just press zoom in. Let's see, we need to change the camera target. If we are zooming in, we should decrement or add, scale by 1 plus camera sensitivity, and if we are zooming out, we multiply. I think this should work, but let's see. Yeah, we are zooming in. Why is this is weird. Zoom out. I think this is because the press and release events are different for the mouse wheel. This is a bit let's see. I was adding instead of multiplying. Okay, never mind. Okay, now it works properly, but it's a bit much. The speed works, but the zoom is a bit too fast. So we will adjust it. Yeah, perhaps we should use a different sensibility for the zoom and the movement. Yeah, let's use for the zoom. I think this is good, but yeah, let's use speed and sensibility. Let's use zoom instead of so what is this? Camera speed. Okay, now the problem is this. We are moving. The movement is smooth because we are using the delta time to adjust for the frame count, but the zoom is instantaneous. So we want to make it more smooth. So instead of assigning this, we will use the lerp function. I think this takes lerp. This takes a weight, and it's from 0 to 1. Okay, this advances the value. This interpolates the the name of the function is linear interpolation or something like that, interpolates the value between the source and the target, and this goes from 0 to 1. If we pass 0, this will always be the initial value, and if it's 1, it will always be the target. So if we do this with 1, the sum will be instantaneous like before. But if we put, for example, half, this will be smooth. But this depends on the frame rate. So let's, for example, let me show you. If we put we put the camera zoom parameter, that is a quarter, and if we have 60 frames per second, it looks like this. No? But if for some reason we can debug, there is a way to force, run max effects. If we put, for example, 20 frames per second here, and we let me debug, print the FPS. Now we have 20 FPS forced by the interpreter. The twins, for example, the system of twins we use for the switching of the map, it works the same, but now the zoom will be faster because there are fewer steps between each interpolation. If we revert to 60 frames per second here, the twin will be like before, but the zoom, it's the reverse. The more frames you have, the faster will be the interpolation that I use here, because you have more frames to approach the target. So if we again put 30 frames per second here, the lerps works like before, but the zoom is a bit slower. It's almost imperceptible, but it's something that bothers me. For example, 10 frames per second will be more noticeable. Look, see? So to avoid that, we should use also the delta time here. So we need to cover, I think, simply multiplying this should work, because let me think. Yeah, this is in seconds, and we want to each second advance, in this case, a quarter of the distance, so to speak, from the current location to the target. So this should work. Let me see how it feels. Okay, this is a bit slow. But it should feel the same with 60 FPS. Let's check. Yeah, it's consistent. But wow. Yeah, it's too low. So the zoom, we will yeah, this zoom, yeah, it's two different meanings. I'm using it to, yeah, this is the amount of, yeah, let's add another variable here, and let's make it a bit faster. So let's use sensibility for the lerp. Sorry. Zoom sensibility, and the zoom, this we should change for zoom step, because this is the discrete step that each click, so to speak, to the wheel will add. This is the step we are moving the target, and this is the sensibility with which we are approaching the target, which is different. So the step, let me check. Yeah, the step will be 1/4. We can use this value and remove the zoom step. Let's see. Now, okay, it's why? Sorry. This lerp. Yeah, we want to. Yeah, we are mixing the two movements, the zoom and the 2D movement. So this should be, let me think. No, yeah, this should be the speed, because we are moving towards the target at that speed. Yeah, and this delta is the you know what, this is a problem, because this is not, no, this is incorrect. No. There is a different concept here, because the speed of movement of the target in the 2D is in fact the speed. It's meters per second. But this is not meters per second. This is in fact sensibility, and this depends on the frame rate. Let me see. Yeah, this should be, why is the zoom out? Yeah, perhaps I should only augment. Sorry, sensibility. This could be greater than 1. because this affects the step. Let's try different values. Okay, this is a bit faster. We need to clamp. We need to clamp the zoom. This is let's clamp between 10, for example, and I don't know, 500. Let's do it. I think this. Okay, this is clamped to 10. Ooh. 10 is too few, and 500. Let's see. Okay. Yeah, I think this is. Yeah, now it's much smoother and responsive. But let's check. This is at 60 frames per second, and it's adjusting continuously. And this is a problem because we don't need. We are making this expensive operation once per frame. So instead of comparing this, we will use I think, yeah, we will use this function that is equal approximate, returns true if the vector and 2 and the parameter are approximately equal by running is equal approx on each component. This function compares two floats and compares them approximately. This is needed with floating point values because the floating point values are by definition pseudo-continuous, so they are rarely equal to one another. It's different. The equality is mathematically different, a concept with floats that simulate real numbers and integers. The integers are discrete, so equals is well defined. But for floats, the equality is a bit tricky. So there is this function. So now we should print only. Sorry, this is not. If it's not approximately equal. Okay, perfect. And we are stopping after certain. Yeah, perfect. So we calculate and stop. Perfect. It's a bit. Yeah, perhaps we should use a custom comparison. This is the map mode. Performance is not so important. Although, yeah, it is important because when we have many levels, let's, for example, let's try first here with 20 frames per second. If it feels the same, yeah, it feels the same speed. Yeah, perfect. And yeah, we stop. it's important to test your game at different frames per second, because different machines have different capabilities. So if we put more, this is, well, obviously in my machine the hard limit is 60 because of my monitor, and we could in theory disable vsync. If we disable it, it will use in theory the FPS rate that we specify here. Yeah, well, the hard limit for this project is different, but it's bigger. It is 300, and the fill is the same. The fill we have. That's important to test for any game, to test the conditions. Perfect. Yeah, in fact, we have less frames. The more levels we show at a time, the less frames per second we have, obviously. But I was saying it's important to test these things, because let's change window vsync. In general, it's a good thing to use vertical sync, because well, it depends on the logic of your game. If you want to do many computations between frames, you limit the frame rate, and if you want a smoother experience, it depends on each game. But what is important is to have the capability of changing these things, the max frames per second and the vertical sync, so you can test things like this, like the smoothness of the twins or the interpolations you make in your game. So okay, let's remove this. In general, printing too many things in the console is also affects performance sometimes in Godot. So you should not print too many things to the console. Okay, I think this is nice progress for a low energy day. So thanks for watching. Please press like if you like the video, and share it with people that could enjoy or learn from these videos. Thanks for watching. Bye.